Hello friends, welcome to VTech Academy. Today in this presentation, we are going to prove some important properties of standard binomial expansion. So in our previous video, we have proved the standard binomial expansion, which is nothing but 1 plus x whole power n. And the expansion of this term is c0 plus c1x plus c2x square plus so on plus cn x power n. So we have some important properties of this standard binomial expansion. So in order to prove that, first let us substitute x is equal to 1 in this expansion. So we get here 1 plus 1 whole power n is equal to c0 plus c1 into 1 plus c2 into 1 whole square plus so on cn into 1 power n. So therefore this would come as c0 plus c1 plus c2 into 1 square would come as c2 plus so on. The nth term cn 1 whole power n would come as cn. And coming over to the left hand side, here we have 1 plus 1 whole power n. So by adding, we get here 2 whole power n. So now let us consider the standard binomial expansion as equation 1. And let us consider this equation as equation 2. Now let us substitute x is equal to minus 1 in the equation 1. So we get here 1 minus 1 whole power n is equal to c0 plus c1 into minus 1 plus c2 into minus 1 whole square plus so on plus cn into minus 1 whole power n. So therefore this would come as c0 plus c1 into minus 1 is minus c1 plus c2. Similarly, we get the next term as minus c3 plus so on, and the nth term would come as minus 1 whole power n into cn is equal to 0. Now let us consider this as equation 3. Now let us subtract the equation 3 from equation 2. So first let us write over here the equation 2, which is c0 plus c1 plus c2 plus c3 plus so on plus cn is equal to 2 power n. So now let us subtract equation 3 from this equation. So we have the equation 3 as c0 minus c1 plus c2 minus c3 plus so on plus minus 1 whole power n into cn is equal to 0. So we know that while subtracting, all the signs of the second equation get changed. So we get here plus c0 as minus c0 and minus c1 becomes plus c1 and plus c2 would be minus c2 and here minus c3 would become plus c3. And coming over to the nth term, here we have plus minus 1 whole power n cn. This would also become the negative. So here we have plus c0 and minus c0, so it get cancelled. Similarly, the terms plus c2 and minus c2 also get cancelled. So now here let us add the remaining terms. So by adding c1 and c1 we get 2c1. Then here by adding c3 and c3 we get 2c3 plus so on, and from the nth terms let us take cn as a common factor. We get 1 minus 1 whole power n into cn is equal to, coming over to the RHS side, by adding 2 power n and 0 we get 2 power n. Now let us take 2 as a common factor from the whole equation. So we get here 2 into c1 plus c3 plus so on plus 1 minus 1 whole power n divided by 2 into cn is equal to 2 power n. So therefore this would come as 2 into c1 plus c3 plus so on. And now let us simplify the nth terms. So let us say if n is an even number, then we get 1 minus and the value of minus 1 whole power n would come as 1. So we get here 1 minus 1 divided by 2. So that implies we get 1 minus 1 as 0 divided by 2. So the value of 0 divided by 2 is 0. So as here the coefficient of cn is 0, we don't have here the nth term. So now let us consider the previous term of cn, which is nothing but cn minus 1 is equal to 2 power n. Now let us transfer 2 to the other side. So we get here c1 plus c3 plus so on plus cn minus 1 is equal to 2 power n divided by 2. So here we can write as 1 by 2 as 2 inverse, and we observe that the bases are equal. So by adding powers, so we get here the value as 2 power n minus 1. So therefore we can conclude that c1 plus c3 plus so on plus cn minus 1 is equal to 2 power n minus 1. Now let us say if n is an odd number, then what would be the nth term of this term? So we know that when n is an odd number, the value of minus 1 would be a negative. So we get here 1 minus of minus 1 divided by 2. So that implies we get here 1 plus 1 divided by 2. So that would come as 2 divided by 2. So on simplifying, 2 and 2 get cancelled and we get the value as 1. So therefore we can conclude that if n is an odd number, we get here c1 plus c3 plus so on plus cn is equal to 2 power n minus 1. So this is how we prove the properties of standard binomial expansion. Hope you understood the concept. Refer to more videos on binomial theorem on our website vtshacademy.com. Thanks for watching. Have a good day.